perpendicular bisector is a line, segment, or ray that passes through the midpoint of a side and is perpendicular to that side. Alright, so if we look in this diagram, these lines, this line in particular, we'll take a look at this one. It's perpendicular to this side because there is a right angle. We know it's perpendicular. Also, there's those congruent marks on this side, so then we know it's going through the midpoint. Okay? What you're going to be asked to do, you're going to be given something like this, and you have to identify what you have. The things to look for, you're looking for right angles, and congruent parts. If it has those two things, then it's a perpendicular bisector. Okay. So, right angles and congruent parts. An angle bisector, again, we've talked about this before, but in relation to triangle, it's a ray that divides an angle of the triangle into two congruent angles. So you can see in the diagram here, here's this line coming from that angle, it's a ray, and there are those arcs. So it's indicating that that angle is being cut in half. So that's exactly what you're looking for. If you're asked to identify what a figure is, you're looking for congruent angles. You have congruent angles. If there's arcs marked on your angles, then you know you have an angle bisector. A median is a segment whose endpoints are a vertex of your triangle and the midpoint of the opposite side. So if we look at the diagram, here's one end of the segment. It's at the angle. It drops down. And we know it's at the midpoint because of these tick marks. So that's exactly what you're looking for if you're asked to identify. You're looking for congruent parts. Only going to have congruent parts. It's not going to have right angles. If it had right angles, then it'd be a perpendicular bisector. So no right angles. Just looking for congruent parts. And the last one is an altitude. It is a segment from a vertex of a triangle that is perpendicular to the opposite side. Here's our vertex. It's dropping straight down. And there's our right angle. We know it's perpendicular, so that's what you're looking for. It's going to have only right angles. No congruent parts. Okay. So medians only have congruent parts. Only that. Altitudes only have right angles. Perpendicular bisectors have both. Okay? Medians, congruent parts only. Altitudes, only right angles. Perpendicular bisectors have both. Angle bisectors are nice and different. We only have congruent angles. Okay? Questions over here? Alright, take a look at some examples. Okay? If we look at number one, check and see first. Do we have any of these angles marked with arcs? There are arcs on any of those angles. Do we have congruent angles at all? No. So can this be an angle bisector? No. Okay. We do have right angles. Okay, we have a right angle right here. But do we have congruent parts? No. So this has to be a what? Well, only has right angles. So we know this is an altitude. It only has right angles. Okay. Nope, there's no arcs on our angle, so it can't be an angle bisector. Look and see. Do we have right angles? We have that box in the corner of the angle. No. Do we have congruent parts? Yeah. Which one of those only has congruent parts? So this one has to be a median. And if we look at 3, do we have congruent angles? Is there an angle with arcs in it? Yep. So then what would this have to be? Oh, but. Questions over that one? And just look at what you have, and that will help you identify what type of lines they are.
Alright. Let's talk about some other tools we put in our toolbox about this one. The perpendicular bisector theorem. Well, the perpendicular perpendicular segment from a point to a line is the shortest segment. It's the shortest segment from the point to the line. You guys have always heard what's the shortest distance between 2 points? It is a straight line. Thunder, guys. Well, too bad. You're safe inside. You're nice. All right, so here we go. So really look up here. If I was at point P, what is the quickest distance to get to AB, that segment? Well, if you look here, there's 3 different choices. You got this little dotted segment over here on the left. You got the dotted segment on the right. And then you got the one straight down. As you can tell, things that are perpendicular, that is the closest distance. All right? So straight down at 90-degree angle is the shortest distance between a point and a segment. Now, with these things, we have to call it corollary. In geometry, when you hear the word corollary, this means the opposite. So basically, it's saying this. I'll be able to read it. It says, what's the shortest distance from a segment to a point? Well, it's still that perpendicular line. Perpendicular line is the shortest segment. Which goes with segment lengths down the road. All right, well, let's look at this other one. We got other things that deal with perpendicular segments. Any point on the perpendicular bisector. So it's that line that goes down and bisects at a 90-degree angle. Any point on the perpendicular bisector of a segment is equidistant from the endpoint of the segment. What do you think the word equidistance means? Gary, what do you think? Think what? Equal distance, so I know the distance is the same. So if you look at this little example over here, if I say that MA, or AM, AM is 8, and I know that they are equidistant as a perpendicular bisector, well, what's going to be the measure of BM? What is it? 8, because I know they're the same. They're equidistant. If we go ahead and show you this proof, it doesn't really matter, but I can automatically know it just shows you why that is. And another reason you know that is, this real quick thing, because these are shared side triangles, this would be the same, since those are the, we'd have to prove that this is 90-degree angle, but we could. And once I know it's the same, it'd be side angle side, so therefore these segments would be congruent as well. We don't need to prove it, don't need to worry about that. Just know that if I have a perpendicular bisector, these segments will be the same. And that's, we'll show you how to do that constructions with isosceles triangles and equilateral triangles. That's how it works. So let's try this out, this example here. If GH is a perpendicular, this is on the back side, so flip over your paper. Just give me a second to flip it over there. Look on the back. If GH is a perpendicular bisector of EF, what is the value of X and what is the value of GE, General Electric? Well, the key word you need to have here is perpendicular bisector. What does that mean? The segment is bisected, EF is bisected, and we have a right angle. Anytime that happens, what do I know about these two values? They will be the same. So you really could draw these little marks in there to say they're the same, but now we've got to use that knowledge to help us set up an equation. So what can I do to set up an equation based on this picture I have up here? Set them equal to one another. Good call. X plus 7 is equal to, or 4x plus 7 is equal to 7x minus 26. Now, not only with that, here's another thing, the helpful tool. We told you from day one, if you were confused on how to set an equation, what's the number one thing you should try to do? Set two things equal, right? And especially when you're dealing with sides. So we had the last test, we had 3 sides, it was like an equilateral triangle. You guys try to add them all up and set it equal 180. very, very rarely do triangles. It can happen, but most of the time, triangle sides do not add up to 180. All right? So when you're dealing with triangle sides, you don't know what to do, try setting two things equal. Now let's go ahead and solve this. I like to stay positive, so I'm going to move the smaller x first. So I'm minus 4x minus 4x. Equal 7 is equal to 3x minus 26. That's you. Again, now we have a bear problem. What's the next step to do? Feed that bear. What do I need to do? Not all once. Not all once. So it's something to do with this negative 26. I'm going to add the 26. Got to feed that bear. This is number 7 over here. So this is 26. He got 7 and 26 gives me a 33 is equal to 3x. Last step-a-roo. Divide by 3. X is equal to, home say, it's equal to 11. We're done, right? Connor, we're done? You're saying no. I don't believe you. I don't trust you. I've got two policies follow life. Never trust someone with glasses. Never trust someone wearing a tunic. Tunic. Like what the Romans wear. Don't trust those things. Kind of like a little cape system. Never failed me. Never failed me. Never trust with what? I trust you now. Don't know why. I trust you now. Okay? So now, what's the next step? I am not done. Now I trust Gary too. What do I do now at this point? I'm not done. What else do I need to find? Well, now I don't trust you. Correct. So what do I need to do with this 11? Plug it in to find GE. So to take, here's GE up there, General Electric. So I'm going to say, well, GE, it did equal 4x plus 7. But I was told that I had to find that side and to plug it in. So it's going to be 4 times 11, because that's what x was. So 4 times 11 is 45. 45 plus 7 is? 51. Hey, good call. 51 is the answer. Doesn't ask for it. What's GF? Yeah, you should have even tried to plug it in, because you know they're going to be congruent. Right? So good. We're good with those perpendicular bisectors? Equidistant? Skip that guy. Let's talk about this other one. This other theory we use, an angle bisector theorem. Well, any point on the, guess what? Angle bisector is equidistant. We already know that means they're equal distance. They're the same distance from the sides of the angle. Well, here's my angle. There's one side of the angle. There's the other. How do I know based on this is an angle bisector? This segment right down the middle. How do I know that's an angle bisector? That red segment's an angle bisector.
Because in the middle.
Well, how do I know it's in the middle, though?
Because the line didn't look like it.
They look like it. So we can trust it based on that. The measures are the same, the degrees. They're both 38. So that's why it's an angle bisector. It bisects the angle. Now, not only that, if I have these angles that are the same, what do I know about the distance from that angle bisector to a side? They are equal distance. So how can I set up an information using those two, that newfound knowledge? What do I know about these two measures? They are equal. So I'm going to say in this case, 3x is equal to 12. Some of you can solve that just by looking at it and say 1 times 3 equals 12, but if not, we'll divide it out. Divide by 3, divide by 3, x equals 12. Am I done? Do I need to plug that back in? You can, but I know it's going to be 12 no matter what, because that side's already 12. Are we done? No! We're going to talk about its corollary. Corollary is the reverse. So I know that if the angles are the same, the distance between the sides will be the same. The corollary says the reverse. So if I know the sides are the same, what am I going to know about the angles? They're going to be the same. And that's what it brings us to here. So we have a segment. We know it's an angle bisector. So I know that distance is the same. Well, if those are the same, therefore the angles are the same. Set up an equation. How do you think you'd set up an equation? For this unit, when in doubt, set two things equal. So pho x is equal to 2x plus viente. What do I do? I like to do the smaller x. Do whatever you want to do, though. Minus 2x, minus 2x, he gone. So 4 minus 2 is 2x, is equal to 20. One last step, divide by x. By x, I mean 2. What am I thinking? Divide by 2, divide by 2. X equals, yes. I could plug it in, but it just says find x. And I know if I plug it in, 10 times 4 is going to be 40. And I know the other angle is going to be 40 as well because it's angle bisector. Questions on those two? Okay, don't pack your stuff up. You need to get out your practice. Yes, in another period, you have a pep rally. Okay? You can pep it all you want.
No.
After next period. Now, what you need to do is have your practice out, please. There's 2 that we have to switch, and you're not going to